Ich will jetzt alles mein Deutsch sprechen. So the rest of the presentation will be in English and somewhat awkward because pretty much the first half of my presentation is predicting the future, which I recently learned is not possible. And I don't necessarily disagree with that at all. I mean, even though it kind of hurts the next hour or so greatly. But I did learn something else during that talk, which was if you're going to predict the future, don't listen to anybody. Just do it and ignore what everyone says. So I'm going to do that. Our company does that often, which is how we created the future of the Disneyland parks, the Magic Band experience. So it's a good thing we don't believe in not predicting the future. I'm also going to talk about the other singularity, which I will explain later. But first, thank you, Dusseldorf. Thank you. I actually work for a company that has a German heritage, Frog, Federal Republic of Germany. Started in Altenstag in the 60s, comes to California. I've never been to Germany before now. This is my first trip. And thank you. Thank you very much. I studied a little German in high school, and I feel like our company still has a very German culture. We often say things like, no, that's how much it costs. Why would it be more or less than that? We told you it will cost that. And the 9 part too. I also would like to thank you. I went to the old town and thank you for the compliments on my mustache. I appreciate them. And Germany, I think, is a country that also took me 30 years to grow my mustache. Seriously, we're not hairy people as Ficklins. It takes us a long time to develop this stuff, right? You can see here the progression of the mustache. This is when it first starts taking its form. This is the first year in 2004 that it took its full appearance. Also the same year I met my wife. I'm not saying there's a coincidence there, but I'm saying that it's a good thing. And here it is today in 2011. Today it's like this. So you can see it's kind of an ingrained thing. So thank you for all the compliments. I worked really hard. It peaked in 1867. That's when it met its peak, way back when. And I believe Germany not only appreciates the mustache, but has given great contributions to the facial hair community over the years. There's some of the greater German mustaches out there. Very creative stuff. I looked for a Dusseldorf mustache, and this is what came up on Google. Ich verstehe nicht dies, but well, it's something, right? The finger stash, which brings an important point. There are design considerations for a mustache. It's something you share with society. Everyone has a comment about it. And so I thought I'd talk a little bit about my mustache and its design considerations. It's in the Fu Manchu family. It's a very recognizable and famous family of mustaches. It's also a very risky family of mustaches. You can get it too long, and then it's quite, shall we say, authoritarian looking, and that could be a problem if that's not what you wish to project. You can also be too short, and then people wonder if you're working in the adult industry, or if you're a footballer. So too short, too long, it's really got to get the length just right. That's the correct length right there. But even then, it's still a risky mustache for the aforementioned reasons. So how do we mitigate the risk? With a little rock and roll. This is something our host Mark has tried before. You add the soul patch, right? A soul patch will make anyone rock a little harder, as Brittany is demonstrating here. I do kind of feel, however, at a personal level, because designers, we get into the details, that this is too square, which is ironic in the English language, because he's supposed to be all rock and roll. this is much better, which is why mine is a little more like Brittany's. So there you have it. A half Manchu with the soul patch is a soul Manchu. I spent a lot of time working on that. Wait, okay, but I was going to actually talk about DIY, the do-it-yourself movement, and the impact it has on design. And I mean capital D design, kind of like we go out and get big companies and try and get them to absorb design, the industrial design, the graphic design, capital D, mercenaries for money design, and how it's having an impact. And I could talk about this because I'm at Frog and I'm a fellow. I've been there for 13 years. I've seen a lot of client work over those years, and it's been a really great time. Also, my Twitter handle is going to cover this. But since the conference is named Play and Make, I thought I would go ahead and prove to you that I do play and I do make. This is what I think a concert lighter should be. It is actually showing the waveforms of Sweet Child of Mine that is playing in the room at the time, if you can just imagine that. It's got a little speaker on the end there. It's going to pick up everything in the room, and it's kind of geeky. I take fire a lot of places. I think parties are a great place to experiment. This is also where I was going to put in the plug for my conference. I'd have one. None of you have heard about it, but it's growing in prominence. It's called the NASCAR Film Festival. Thank you. It takes place in the fall in Texas. None of those people are attendees except for the guy in the red sweatshirt. We've grown to 6 attendees at this point, but I hope next year will be a lot better because we're up against Formula One. They don't know what they're up against. I never give up a chance to experiment. This is a crowd-sized step sequencer. It's actually the bottom of one. They're hard to put together. But what it is an instrument big enough for an entire crowd to participate and play at once, and this is kind of what it looks like in action. I won't play the music for you that it makes, because to know beautiful, you must know ugly. And we thought that was a guiding principle that might help the people make beautiful music, but instead it mostly sounded like a casino the whole time. But it was a lot of fun watching them interact with these things, which is what's nice about doing this kind of playing at a social event. This is a life-size electromechanical game of Pong. This is one half of it. You can see they're playing another half and another part. It's 30 by 60 and 30 by 60. And so you got to move your big puck back and forth. It's all very big and very dangerous and would not pass health and safety. Sometimes this comes to where I make. These are all very unique interfaces I have worked on over my career involving multi-touch or interesting stuff. Some of these products made it to market, some of them did not. But I'm really interested in really unique interaction models, which is one of the reasons I play, because it helps me to make them. I also think about technology as having this role of enabling brand new experiences, like a giant light bright that allows you to walk up it and kind of set whatever color you want. This is a provocation we did for last year's South by Southwest party, and all those lights, there's 2,500 of them. They're IR addressable and remote control, and we put them into this 9-foot by 32-foot long wall, and everyone can paint whatever color they want with them. And the provocation was that next year, that technology is going to cost about half as much as it did the first year. It costs us about as much as like a really crappy used car to build that. So imagine it gets half the size and twice as many lights. Next thing you know, you have a custom wallpaper. And if there's a really scary movie on, it can be really scary lights. And I like that idea that we live in a world where the ubiquity of technology is making it cheaper and enabling experiences. Also, it can change experiences very profoundly, which is what a lot of people debate, but I don't want to live in a world without, optimism, or even an optimism bias. So here's a bar that we made for South by Southwest party 3 years ago. And what we did is we have RFID readers clamped to the bar, and we have a projector, and we gave everyone as they came in the door RFID tags, and we told them the beer is free, except it might cost you your pride. Because if you look closer now, you'll understand it. Right there at the top, it's telling us how many beers have been given away. When you scanned, it came down and told you that animation, how many, that the beer was on the way, and then it told everyone else how many you've taken that evening. So if you drink, and the 277 is the bartender, by the way. I know you're asking, you're like, what can it fit? But there are people who've taken 20 there. They're probably taking them for their friends, I hope. It wasn't in Germany. And then I have this. There was some talk of skeuomorphism earlier, which is, taking a digital object and making it look real, giving it the properties of real, thereby gaining intuition, making the user experience simple. This is what I call skeuorealism. It's taking a real object and making it so much digital so it's kind of a bigger hassle to do things. And I'm using it to change my slides. At the party, we set it up and projected on it with the provocation that someday soon light will be cheaper than ink. Because a large format book like this is very expensive to print. But this little sensor and an ultra short throw projector are getting cheaper every day. And we kept track of how much it cost to build all of this. And it's funny, I'll turn back here so you can see that we didn't, there's opportunity abounds here to do something interactive, but we didn't. We just put the Gutenberg Bible out there, and people just had to turn their way through it because it would be cheaper to do that than to print a 2-foot by 2-foot large format book. Light will be cheaper than ink. So sometimes we imagine technology always adding to experiences, and we forget some of them are going to change profoundly just because it's a cheaper way to do something. And I think we're impacting that every day. And then we made this little guy. He's a robot. He looks a little like a Roomba. He operates like a Roomba, except for he has saw blades for wheels, and that was to get traction. Runs off of my little laptop there, and what he does is rakes a Zen garden for you. Which begs the question, is that even a good thing to do with technology? Yeah, the whole point is to rake it yourself, right? Not buy a robot to rake it for you. Or maybe that helps you meditate more because you're really bad at raking. I don't know. But I think at an ever-increasing level that technology is going to start showing up in unexpected places, like these augmented reality porta potties, which I created and I think are the best use of augmented reality ever. And this is what they do. They tell you great information, like what bathroom is available. They tell you how long the people who are in them have been in them, which is pretty good knowledge. And they also tell you if people have been sitting or standing, which is really good knowledge. And such a thing I think I have a new model that I'm bringing out recently that it's going to cost me about $40. So wait till they come down to $20, and you might start seeing them at your local fair. I think of the millions of Galaxy S2s out there. I'm not even going to have to go into circuitry. I'm just going to use a Galaxy S2 per each porta potty because people are basically throwing them in the toilet right now anyways because the Galaxy S3 is out. So why not use them for something? So that kind of thinking and that playing really comes in handy when this happens, when someone comes and says, I made this awesome sketch, and this is what the future is going to be. Could you go and make that, Jared? And then you're in a really hard starting place. But if you played around with a lot of technology, your mind is a better place for it. So that's kind of what I think I do. I think that a lot of people in this room do this too. Designs with technologies. So I kind of consider myself a design technologist. Kind of an accident of the English language, because we say graphic designer, who handles the aesthetics, and we say interaction designer, who handles a lot of the organization. We even say, but we say design researcher, and we say that has to do with design. You say design technologist, and everyone's brain shuts down. They say, how does one who is involved with technology design? Well, I showed you a lot of cases, and I'm going to show you some more, that one can design with technology. You can use technology, especially well-suited for concepting, early design research, and interaction design, which I think flies contrary to a lot of conventional wisdom, but has actually been most of my career, and probably most of yours, even though you weren't getting credit for it. And if you're an interaction designer, and your world is all wireframes, I would say learn to code. Because time is ticking on that game. I count myself as a professional maker. There's a whole movement, the make movement. And I feel like I found a home the minute it was given a name. And it's fantastic because I've always been taking apart these things in my home since I was a little boy and assembling them. It's my hobby, it's how I spend my weekends, and it's how I work professionally sometime. I would read this book. It's great science fiction, and it's the hardest kind to write because it's set only 20 years in the future, in my mind. He doesn't actually ever say. It's written by Cory Doctorow. Get the Cory Doctorow version of Makers, not the other one. And since I'm recommending it, I do have to tell you that there is a rather explicit sex scene when he gets to Ann Arbor. You know where that is, and you can decide whether to read that or not. If you skip exactly 3 pages, you'll miss the whole thing, and it really has nothing to do with the plot whatsoever. That's up to you. So back to what I was going to talk about, DIY and the impact on design. But first, I feel like I need to set the stage a little bit. All right, we're experiencing a rise in the digital lifestyle. Okay, so I'm going to set the stage here. All right, what we have here is the peak operating efficiency of the personal computer 30 years later, right? And we carry it around everything. So I'm here to inform you that the entire history of computing has led us to a place where we are essentially babysitters. We have this thing, we love it, we put little clothes on it. It cries when it's hungry and we feed it. Cries when it's not hungry and we feed it. We take it everywhere. We give it names. We regard it as almost a more youthful version of ourselves. We really, really love them. We regard them highly, take them everywhere. And we use them essentially to live 2 lives. Our life. That might be more my life. I'm sure your life is different. At least what I've seen on Facebook, it's a lot different. And Instagram, even better and stylized. And there's the other guy. That guy represents our digital lifestyle. And this thing, with all its capacity for communication and social networking, has created a tunnel into a digital lifestyle that we really enjoy living beside our real lifestyle. It's very valuable to us. And I say tunnel for a reason, because this is a pocketable, immersive tunnel with 50 lights at the end. It's not the proverbial single light. Like, you go in to check your email, next thing you're doing is a bunch of other stuff. And when you're in it, you're really in it. There's a biological imperative at work here. Your brain literally thinks you're looking for a lion in the brush and closes out the rest of society. It's so immersive that people will literally walk in front of a train while using it. I know, or a bear, happens too. You go on the internet and find dozens of these fountains, whatever else it is. But all that really tells us is how valuable these are. This digital lifestyle is so valuable as we will choose digital immersion over the physical world or even our own safety. It's so contrary to the laws of evolution, or maybe it is evolution. I'm not sure, but I do know it denotes value. Another thing it's leading to is, and here's where I get all kind of pop-sci. So I better have some more Red Bull. It's leading us towards the quantum subconsciousness. So what do I mean there? So we have with us ever-present information and communication at a breadth, a depth, and a speed unparalleled before. Up until now, we didn't have that, and we really thought that stories and archetypes were passed down, and that they were started at an event and through a series of causation and shared ancestry, that we shared common ideas. There's a lot of writing about this. I actually think that because of the 11 dimensions of superstring theory and quantum entanglement, anytime you have a moment of inspiration, you're probably sharing it with 10 other people at the exact same time. And this is how all these ideas spread around. This is my little pop-sci moment. It's quantum theory. So that means if you have a moment of inspiration, you better act on it. Because a lot of other people just stole it from you. What it means to the bell curve product manufacturers, which I spend a lot of time designing for, and you probably do too, is that in the time it takes to get to the market with a product like that, you lose the notion of innovation on your product. It basically becomes, this is my saying, the Chevy Volt is pretty much a Christmas sweater. But we're all given this promise of an electric car. Chevy Volt, it was a pretty sexy promise. 4 years, $400 billion later, and it comes out, and it kind of looks like it was designed by a committee of baby boomers. And therefore, it's a Christmas sweater they gave to us with full intention to take it out of our closet later and drive it. Which is appropriate. And the reason why I think that is because in the meantime, in our heads, we decided that this was what an electric car was. This is the Chibi cart. You can debate me on how much money actually took to build it, but after getting into MIT Media Lab, Charles, I don't know how to pronounce his last name, Juan or Guan, but he built this thing in a weekend, just 35 miles an hour. Runs for a good 45 minutes on a charge, and it looks a lot more fun to drive than the Chevy Volt. But you see what the bell curve manufacturer is contending with. This kid's out there offering fun, and they're offering a sweater. It leads to the new nightmare and paradox of the product designer, and that's you have a really good idea or moment of inspiration, only perhaps even spend a few $100,000 on design research, and in the middle you find it on YouTube, which is very awkward for you and your client, unless they put it there, or unless you put it there, which I'm trying to convince them is not a violation of NDA. Worse is when it shows up on Kickstarter. Now you know you're really in charge. So these are new nightmare. What it really dictates, and pardon me, this is one of the flaws of this system. You run out of pages. Well, the good thing is they're blank, so I just start over. All right, so what we're really talking about here is the rise of the makers, this whole community of people who believe that they can have any product they want if they just put their sweat equity to it, are causing these consternations to the professional design industry and the bell curve product manufacturers. And the way they do this is by the formation of Adhocracies, which is another Cory Doctorow concept from Down and Out in the Magic Kingdom, which is an awesome book. And it goes like this. Used to be, if you wanted a Cthulhu pony, you had to teach yourself to sculpt, make a Cthulhu pony, and then find someone who would do setups, pay the immense setup costs, and then get a Cthulhu pony back. Or teach yourself how to fire one and build a kin. Now, if a whole group of people decide they like Cthulhu pony, they design it together, post it on Thingiverse, right, and then they just print out a whole copy of them. A bunch of Cthulhus, you have a new form of math customization. So an adhocracy is basically a group of people who is so passionate about an idea, they're willing to work together to make it real. And now these adhocracies can sprout up as teams across the world and whatever, and it doesn't apply to just Cthulhu ponies, right? They're smartphone adhocracies that say, don't even care that Apple, as big and litigious as they are, left out a feature, they'll just put it in themselves. That's a powerful thing to contend with. Or GPS adhocracies. I don't like your form factor, TomTom, so I'm going to make a pair of GPS Oxfords. These are shoes that will show you how to get somewhere. The circle gives direction, and the right shoe gives distance, right? And then there are lawn care robot adhocracies. This should have been iRobot's next product, but some guy made it on a weekend for Instructables, and you can get all the parts for about $200, and what it does is one of the lawn chores that happens in the US, where we keep lawns, especially in Texas, is spreading new seed or fertilizer or whatnot. This guy just goes around and does it for you. A couple $100 in a weekend's worth of effort. Now, what does this do to all the people out there and the bell curve product manufacturers? Well, now we're dealing with this new desire for mass customization. People are watching this on YouTube. They're seeing the Kickstarters, and the opportunity abounds for a total mismatch of expectations. To overpromise, underdeliver, or even promise what you want, but end up underdelivering because something newer or cooler came out. Or it wasn't the idea. It was an exact match to what they had in their idea, which they now believe that they should get from you, pretty much. And they're doing so more every day. The next thing we're contending with is shifting patterns of computing. Multi-touch was a great advancement. But from there, Things are getting cooler, way different. We now have physical computing. The interface doesn't always have to be the computer itself. It can be just a like button you press on the wall, which I believe was created by someone here in the room. Mario, I love this thing. I like it. Right? It also comes about because of this, okay? This thing we love and we take everywhere, as I explained before, has certain shortcomings. And I like to describe these shortcomings by talking about moments of shame, fear, frustration. And we've all had them. Let's start with fear. Fear goes like this. Oh, I just went to the Canary Islands. Let me show you my photos. And you hand your phone over to someone, and as soon as they take it, you go, don't swipe. Please don't swipe one more time. That smartphone fear. Frustration would go like this. Oh, what's the weather like? Oh, why am I even digging this out of my pants? Why am I now unlocking this? It's exactly what Louis C.K. was talking about earlier, right? We're frustrated. Why can't I have the weather now? Why do I have to go through a lock screen to protect other people from finding out what I would see as the weather, which is the same thing they would see? And then there is shame. And, you know, even by the time I quit dating, these things already existed, and you would be sitting there, and you reflexively pull this thing out, and you're like, ooh, I feel really bad about bringing this out right now. Another moment of that is like, say we're having an argument about movies. Like I said some radical things about Prometheus when I was telling you about my sequel to Prometheus, which I'm creating, which is called Prometheus Down. And if you want, 20 minutes later, I'll tell you all about it. It's really good. It's going to change everything you think about Prometheus, especially if you thought Prometheus sucked. We can make a sequel that will make it better. It takes 20 minutes later, better when we're drinking. You guys already are. I need to get a head start. So we'll do that later. But I might be talking, and you'll pull out IMDb, and you'll start looking up a fact, and then I'll be like, oh, I'll pull it out too, because what if you looked at it and you lied to me? So I'm going to check you checking me. And that's just all shameful, right? But it shows where the limitations of this device are. We don't want our digital lifestyle to be locked into this device in our pocket. We actually, our new values that we're wanting and expected, and they were described by science fiction so many years ago, and they include things like being heads up and present. I like this book because it allows me to look out at you guys instead of looking at my screen. Cooperative, that's something you can't do on a smartphone. We've all been in the room where let's go to lunch and everyone whips out their phone, you got 7 copies of Yelp going, right? So we need a cooperative commuting experience, and we want things that do digital markup of the physical world, especially for this casual stuff. It should just be right there for me, okay? But to get this, so yes, a lot of people kind of said this will be the next pattern of computing, and these guys are really groundbreakers, and it is kind of funny, but I mean, what if I made it prettier for you? I mean, it is coming. I don't qualify as this as the next pattern of computing, though. I call it heads up and personal because it isn't shared, but it may solve some of the heads up problem. So where will we get this? Well, to get really to the next pattern of computing, we need to stop doing this. We have this metaphor built up around the computer that it's like the human body, and it can never be greater than human, right? It's got a head, it's that memory, that's the hard drive, and it's got a heart, that's the CPU, and all this kind of stuff, and that it has to be a singular corpus, like one object. And that's just not true. The computer is really not even that anymore. It never even has to be a physical object. Phones aren't just getting smaller. They're losing their physical identity altogether, right? They're just apps. Where are the buttons anymore even, right? Our desire to take them everywhere is creating this vast infrastructure for having data and computing power everywhere. And it's already fractured into personal networks and public infrastructures, right? And then our desires to get the best efficiency, peak operating costs, and information about our buildings and everything else in our cities has put sensors everywhere and has created computing that spreads out to the point where we call it cloud, like it's covering all of us, right? This means that something like this can be a weather app. Just put enough computing power into it, and this is someone else's demo, and I'm sorry I've lost all the stream of attrition, but it sits in your umbrella stand, and if it's going to rain, the light is on, so you pick it up and take it. No unlocking your phone, right? That is a computer. It is an app. The city is the new computer. The computing is to be all around, it's fully ubiquitous, and I like to think of the room as the new computer. And I'll talk about that a little bit more later. And it's happening, though. You think Microsoft is putting the Xbox One in your room, like your living rooms, with always on, just so we can play Forza? No, it's a great bulkhead for room-size computing. It only needs a few little accessories before it's really allowing you this kind of like heads-up and presence, and the possibility for cooperative gaming becomes cooperative computing. Another Trojan horse is how cell phone companies and cable companies are branching out into home automation and control. That's just the first step. They're just getting the sensors and the servos in place, and pretty soon they can be able to use them to fulfill this kind of like ubiquitous computing. The car. I like to say this is one provocation. The car is not a personal computing, even though computing is coming into the car. Right now they're simply putting iPads into the dashboard, which if you thought this pattern of computing was unsafe for walking, try it for driving. So I think it's a very bad idea. Not that I don't think we don't want our digital lifestyle in the car, we do, but the car is a room. We share it with 4 people, or we ourselves in it, and it has the properties of the room, so it needs a room-sized computing pattern. And to get there, we're going to need new patterns altogether. The whole mouse, monitor, and keyboard, visual pun, old frog design, is not going to cut it anymore because touch and keyboard, they kind of require a certain amount of closeness, and rooms are very, very big. Well, we need our room-sized inputs like voice, computer vision, gesture. And what we need are room-sized outputs like large format screens or clear screens, or projection is one of my absolute favorites. Okay? A very interesting thing to bring this back to play and make is that in this arena of new inputs, the makers very much are influencing this conversation. Microsoft is not leading this conversation. As soon as they released their device, people hacked it, and a whole adhocracy prescribed a whole new ways that these interaction models might actually work. And that means that sketched visions like this are a lot less powerful than they used to be. In fact, they're kind of like, okay, Vaporware, which changes our whole industry on its head, because we used to live and die by those kind of cool sketched or modeled visions. So this is where we're left. We have this rapid propagation of ideas. We have desire for mass customization. We have these expanding interaction patterns. So I'm just going to say some blanket statements here and then go on with examples, right? You got to get to market faster. You have to design open products that can evolve with the user and that the user can evolve themselves. No more vertical stacked and locked in ecosystems. And be open to conventions moving upstream. We're so used to telling the consumer how the design interaction is going to work. Might have to spend a lot more time watching the community tell us how it will work. The capital D designers. And that's exciting. And this is where DIY at Frog really comes in. Okay, because if we have this problem, a mishmash of features and interaction models, you lose conventions, and conventions are so powerful for designing. So what do you do if you have to come up with a new interaction model for a new input methodology and you have no conventions? Like sticking internet and a screen onto an oven. The oven was solved a long time ago, and now people wanting it to be part of their digital lifestyle. And how are you going to get that right and not just frustrate them? Because an oven like that, like the setup engineering costs are only a few $1 million. Or what about this? The cell phones just have buttons, and now the buttons are gone. Multi-touch. How do you do this, right? This is how we've taken to doing a lot of it, and that you may be doing as well. And that's, we think by making and we deliver by demo. Principal Design Technologist Joshua Noble brought us this saying. I love it. It's now my credo. It's kind of what I've been doing for a lot of years, actually. We call it user experience simulation in the case that we're doing interaction models. That's where we use an expedient technology defined as, for me, anything that runs on a virtual machine. So Flash, HTML5 stack, all that stuff, all that just-in-time compiled code, because it scales with hardware. You can just throw hardware at it and it runs faster, and it allows you to write procedural code, which means you can code so fast to a single purpose without worrying about extensibility that you can spend more time designing interactions. You're going to throw it away and really code the product later. You use that for a gut check of these viability of these interactions. We employ this when we need an interaction model. I like to pull out haptic or interaction choreography. Those are good signals that if people are wanting voice, gesture, or some elements of multi-touch that don't come in WebKit, that you have left conventions and they're weak, and new innovation is, sometimes clients just say, I want to do something different. Different looks good on paper a lot, and then halfway through production it feels really bad. So you got to test this stuff really, really quickly. We've been doing this for a long time. This is one of the first mules we built, and mules is what we call them. It's like 2002, back before there were touchscreens and iPhones. But this is probably a more relevant one, and these are all old. There's a funny thing clients have, and that's they don't want you to show the product they're working on now at conferences. And they tend to like not give us permission to show the work until it's like 5 or 6 years old. So that's, but I mean, it's relevant anyways. This is one of the first touchscreen printers. HP was going to bring it out on the market, and of course up till then, printers had been these big button trees that you had to play with. Now we're going to add a touchscreen to it. How do we make that work? Well, we design it virtually. We create a big hunk of plastic that looks like a printer. We put in fidgets, we put a keyboard emulator, we put a VGA screen, we put an LCD, and we put a fake power cable on the back that goes to a desktop computer sitting underneath the table, where we're going to do about 50 rounds of usability testing and run everyone from German grandmas to Saudi Arabian citizens through interfaces that we've created rapidly a week at a time. We actually did go through about 56 iterations of this before it hit the market. And when the usability testing, it was really cool. People could stick in their SD card. It would read the photos. And I wrote all this in Flash. There's so many hacks going on. It was really cool. It was drawing on everything I had done in my playing to make this happen for the users. And at the end, people would reach out for the print, and not even realizing it was a hunk of plastic. So we got really good feedback before the engineering setup costs, right? So successfully, actually, that the engineers that normally program these things and had a lot of work to do setting up these chipsets and everything, they had 3 months of extra time. The guy is telling us, he's like, we have 3 months. Normally you spend 3 months getting the first version, but now we have a working simulation of the entire design spec. What are we going to do with these 3 months? And we said, how about write a software rendered animation library so you can include our transitions, because they're quite useful to the user in terms of setting up an information architecture. And they said, that's a good idea, and that's what they actually did. So the product actually came to market with more capability, and that saved a lot of money, because they could have gone to market and then had to re-engineer and gone to market. That'd be very expensive. That's what we call return on investment, and that's how you sell this kind of work to clients. This is SanDisk Fuse. It's an MP3 player that had at the time, not a capacitive pad. I want to show how low the fidelity could get. This is like weeks in. We started in just black and white, thinking, could we make a two-dimensional interaction model? Kind of similar to what the Fuse came out, but at the time it hadn't come out yet. And what I meant is, what if your parents and your siblings are parents vertical, siblings wide? At the time, all you could do was yo-yo down and up, right? Artist to the songs they have, to a single song, back up to songs, back to artists. And what we wanted to do is go to artists, and then if you went sideways, you could go to the next artist in your collection, next artist, next artist, next artist. And if you went down to album, you could go to the next album, next album. If you went down to song, you go next song, next song. So it's a two-dimensional architecture. It's the kind of thing when you tell people, they say, a user is never going to get that. And you say, no, wait, I think a user can get that. And you go and you simulate it, and then you build something like this that I call Soviet chic, which is a stripped apart math, some push buttons, and you hook it up. All it's doing is firing key commands. We kind of wrote a little C hack to keep centering the mouse, and you put it in front of them, you do usability testing and make changes. This saved the whole red line specs phase of the product, and here's what we just handed over to the engineers. Thank goodness they got rid of that Perl and went to a capacitive. We were telling them that right from the beginning, and Didn't really help though, because the iPhone came out and just killed this whole product category. But I still think it's a pretty cool device, and you'll see the final result actually was very similar to what the simulation was, and it saved a lot of time. So we're now designing in 4 dimensions. We have transition, we have time, we have animation, and when you're doing that and you don't have conventions to draw from, we're starting to have some, and that's great, because the users understand them, and that means you can wireframe it out and everyone understands. But if you're wireframing something that you think is going to be good, you need to gut check that viability as quickly as possible, and that's a good time to call us design technologists. So first, play, make connection. And the first way that DIY movement has really profoundly affected the way that we actually work every day. All right, so the other singularity. I like the other singularity. Everyone who here knows what the singularity is? Raise your hand. Okay, so the singularity, and it might be a language problem because I only saw half of the room, is this concept, largely in science fiction, but also with futurists. And it's this moment in the future when machine intelligence surpasses human intelligence. And we often measure our progress to it with something called the exponential technology curve. This is a tracking of Moore's law coming into being. So what it is that's the price of computing power over time. And as you see, it rises exponentially. And there's this association that not too far in the near future, in 2045, we'll be able to do more memory and more calculations than the human brain will have enough parallel processing to accomplish it. And at that point, computers will become more intelligent than humans. There's an interesting area below that exponential technology curve, and I call those the cast-offs of the exponential technology curve. When we're talking about the singularity, because of the great possibilities created by inexpensive and plentiful computing power, the visions, they get really lofty, right? Ray Kurzweil will talk about superhuman capability, like respicytes, these little nanobots that will allow you to sit at the bottom of the pool for 20 minutes without breathing. The end of Maslow's hierarchies of needs is a common one, because artificially intelligent tractors will be able to plant enough crops for everybody, won't have to worry about hunger anymore. Or even eternal life. Ray famously says that he will be able to back up his own brain. And those are very lofty pursuits. And then there is the other singularity. And it's said a little more like the other cousin that you have and that no one wants to talk about. Which is to say that humans, being what we are, cannot resist taking cheap and plentiful technology and putting it towards more mundane or prurient or childish pursuits. And another way of putting this would be, somewhere on the Star Trek Enterprise, there is a SkyMall catalog, filled with all the things that the future has to offer us that don't have to do with eternal life or solving world hunger. That is the other singularity, and I have played with this concept before quite a bit. A lot of those examples I showed earlier were from our party where we examined the other singularity and all the impacts it might have. You see it a lot in marketing today, especially with quadricopters that are artificially intelligent or whatever they want to call them. But that's not the end of the story. There's another very interesting side to this, and that's that the cast-offs from the exponential technology curve are creating a new class of products, right? Things that used to be so expensive that they had to justify themselves by doing many tasks, by multitasking, now only have to do one thing. This is my for instance, and we can argue about it later because geeky crowds like to argue about it, but really you can say basically that first iBook G4 and the ARM that's in the Nest thermostat, about the same computing power. Right? They use that extra computing power to offer new capabilities or elegance or craft. So in the instance of the Nest, you give it your wireless, your SSID, and it configures and programs itself all by itself. That's the new out-of-box experience. It's awesome. The cloud is your out-of-box experience. And algorithmically, it continues to program itself and is the best thermostat. I've owned 3 of them. I think they're great, right? That's the wrong way. More Skeuomorphism. This is a whole new class of products, right? Some of them are as simple as just like Roku does one thing, streams, or a Chromecast, one thing, streams. Or Canary, which is similar. You sit it in the room, it's turned the whole security market on its head, has enough sensors, and listens to the room for the week, and builds an algorithmic pattern of how you walk, how your dog, what the temperature, what time of day, and then it uses that pattern to decide if something's a security threat or not. You buy it for $250 once, no subscription anymore, and if you leave your house, you take it elsewhere. This entire new class of products is very disruptive. That's a car from Audi that uses all its kind of brains, and here's one from Volvo, not to drive itself down the freeway, but just so you can get out of it, hit a button, and it'll go find a parking space for you. And it can do that a lot better than you because it can drive really slow, take its time, and it can get into a really tiny spot because nobody's getting out afterwards, and it doesn't feel embarrassed about its parallel parking skills. And I think you're going to see those a lot sooner than you see self-driving cars because they're not going to have a lot of political weight or judgment of safety behind them. So this leads us to a new sub 1,000. The old goal used to put a single computer in someone's hands for less than $1,000, and the new goal is to put 1,000 computers in the home for less than $1,000, and each one of those computers is dedicated to solving a single problem with intelligence, elegance, and craft. And a lot of them will be Other Singularity products. This whole idea that Apple is going to control your entire home, we may not have to deal with it. It may actually be just a bunch of 1,000 individual ad hoc products that you buy, and each one does what it's supposed to do, and you don't care if they're connected. This leads us to a unique place. When you start thinking of these kind of technologies, this unique place is somewhere when something is innovative and visionary. Innovative, it's a brand new technology. Nobody knows it. Visionary is an old technology, but used in a new way. In both cases, the consumer is not familiar with this anymore. It gives you a very difficult problem. It's a design research problem. That is, if you go and ask them what they will do with that technology, at least in most Western cultures, they will lie to you. They don't know, but they won't say that, so they just make up bullshit. And that bullshit can get all the way into your product. It's a problem that's very expensive to get around. You do a lot more design research. One thing we've started doing, though, is a shed. Shed is technology-driven structured brainstorming. Okay, let me describe it quickly for you. We use all the tools of the make movement and the modular micro circuitry, any expedient technology possible to where if you were to ask the question, what's the impact of computer vision on automotive controls?
Blind spot. Okay. Blind spot. Okay.
We answer that by building a voice-controlled mirror. And seeing how it feels. Okay? It makes vision stuff like this work. By the way, if you want, we call that the Jedi Mirror. It was just an exercise. I can tell you a few things. One, yeah, you could do this and it would move around. I think even before we built it, we knew that was stupid. But after we built it, we were like, that's really stupid. Because your hands are supposed to be on the wheel. This whole thing, we're like, kill people. But that blind spot thing, we're like, if that could get fast and responsive enough, would be really, really interesting just to be able to say blind spot and have it catch it for you, or even notice a glance as you looked over. So just by playing in the technology, it's the same as sketching on a whiteboard, but it's different. It wasn't really our ideas, okay? It wasn't really, because we were working in the technology, we were guided by it as we worked in it. Here's another example. This is what I call Room E. So they really did give me this kind of thing and said, what are you going to do? And it deals with what we were talking about earlier, the next patterns of computing, right? And these are all more of those vision renderings, like, are just not so useful anymore. But they have a lot of great ideas in them. They're not new ideas. They're in all kinds of corporate videos and stuff, but we wanted to talk about why it doesn't exist yet, and there were a few things we thought about, and one was everyone's kind of thinking they're going to have to build a whole new house to do this. Well, but what if a projector and the sensors you needed could all fit in a form factor like that, where you could just screw it into any light bulb cam. Now, any horizontal surface could become a computer output. There's a company called Luminar that you can look up that's working on this. They have it this big now. It won't be that much longer until they have it that small, right? Or what if it was just a wall switch? So this really could be retrofitted in your home. We had to break that mental model first, and then we had to start asking, well, room-sized inputs and outputs. What we really kind of were thinking about a lot was what's not shown is the interaction model. Science fiction has described all these value chains and these executions, but they haven't talked about how it all worked together nicely. And so we did what we did. We did a shed. We went and bought off-the-shelf technology and started playing with it. and came up with room E. I have room E, at least portions of it, with me right over here. So let's play a little. This is a little like juggling, just so you know. The juggler sometimes drops the ball, and the audience feels terrible. But the juggler does not. He drops the ball all the time. So the tech demos, when you do them live, they're a little like juggling. So let's see how this works. All right. So, voice computing. Today, it pretty much goes like this. Computer, is it dark in here?
Yes, the room is quite dark. Would you like me to turn on light 1, light 2, or all of the lights available?
No. I'd like to slap you. That took too long. That's the form of natural language computing. And if our roommate talked to us that way, we would be quite frustrated with them, let alone our loved ones. It's quite useful for concierge computing or moments of distracted, but what we found quickly when playing is there is an uncanny valley of voice when it comes to the room. You just want things to happen, which kind of leads you to the next form of voice commuting, which is kind of like this. Yeah? That's one way. Computer, turn off the lights. Like that. Computer, turn on light 1. Computer, turn on light 1. And that's about how it works, right? Computer, turn on light 2. There we go, okay. Computer, turn off the lights. Okay, a couple things about that. I feel like Jean-Luc Picard. That's what we would call command computing, and it has a couple problems. One is how foolish you feel doing it. You're not Jean-Luc Picard, and only Jean-Luc Picard can be Jean-Luc Picard. The second thing is that, yeah, okay, there's 2 lights up here, but what if I have 100 objects in my room, I have 100 commands to remember? That's really bad. And so then we said, well, but the computer can see. So what if we put in a little social mimicry and started doing this the way that a human does it? All right, so let's see if this will work. I think there's a light here we could turn off that would help it. We'll see. Computer, turn on this light. Computer, turn on this light. Well, let's try again. Computer, turn on this light. Turn on that light. Turn off these lights. Right? Thank you. Juggling. So, and of course, I mean, we might not have to say anything at all. I mean, we could just like do that, right? That's a lot easier. Show me the weather. See it right here? I have to get out my phone. And it knew where I was looking, so I put it where I was looking. Make it warmer. Warmer. Another problem with command computing. I could go on with that all day, so maybe if I just did that a little easier. So now you get it. So basically, that's the way we would negotiate it amongst humans. If I said turn off the lights, he knows it's his job to do it, and the rest of you know it's not. That's social mimicry, and we could use computer vision to do that, and it would make a lot more interesting system that we call conversational computing, right? And here's a video of more of the scenarios welded together. Skeuomorphism. I'm really dedicated to this too, aren't I? Like, I just want it to work. Ooh, it's pissed at me now. We use machine learning algorithms for this, and apparently the way I wrote them, their machine doesn't learn very well algorithms.
Turn on the lights. Turn off this light. Turn off that light. Turn on these lights.
Couple other scenarios.
Jerry.
So I know I'm in the right meeting room now. I know what the Wi-Fi is because I'm a
Show me the
guest.
backyard.
Computer vision
Hide the
tricks.
backyard. Show me the weather. Make it colder.
An interesting note here is
Colder.
like, these little projectors that are so cheap, people think they're terrible because they're trying to look at photos with them. But if you're just projecting numbers on the wall, they're awesome.
Let's
Work in
order
full
takeout.
daylight.
What did I order last time? Order that.
I'm going to repeat that same thing.
Let's order takeout. What did I order last time? Order that.
This entire room is a computer. Knows where I'm looking.
Reply to this tweet. Say, this video is awesome.
I know I like my own videos, huh? Here's another. How do you handle false positives?
Turn on the lights. Turn off the lights.
It's not listening to me.
Turn off the lights.
It only listens to me when I look at it.
Turn on the lights.
That's the way humans work. It also like negotiates the crazy guy problem. And then if it knows you're looking at it, maybe it should have a presence in the room. And participate in the conversation. You saw it once and he does it here again. It's such an this is Goose, he's in our Amsterdam office, and this is his creature Wink. The room is a computer. But the more important thing I think here, some closing thoughts. I'm almost done here. Then we can talk about Prometheus down in the lobby. You're a design technologist, or you might want to be, or a designer. In the hands of a design technologist, the technology can create the concepts for you. All you have to do is work in it in the right way. Don't look for possibilities. Don't look for just simple possibilities, right? Rather than asking the user how they will use a new technology, it's a new word I put up there, use a new technology. We ask the technology what experiences it can offer that user and the ones that they will value, right? If you've been working with users or consumers long enough, you are one yourself. It's okay to go out there and be brave, work with the technology with your knowledge, but rather than just create raw capability, ask it, what would you do that users would really like? And then try and make it do that, and then see how it feels, and then treat it like the game of golf or kissing, right? Like most of the time you're doing it really badly, but that one time you get it right, you know it's right. So you can actually feel it, and that's like really a design concept that you can then judge viability with. All right, and then we make videos to hand off to the client when we do this for them. We also make documents to do the principles and everything, and that's a good thing too, to help describe and hand it through them. What they really end up is with a bunch of, is something that they can do decision making with. It's really good. So just to summarize, we're living in the age of the digital lifestyle. There's a whole new class of projects. We're experiencing the rise of the makers. Think by making, deliver by demo. Love what you make. And the day of the ecosystem, it's closing. There's all the really big things in technology for a while have been invented, and now we've left ourselves a really messy world, and we just need to go out there and close the small gaps. And great value can come from closing small gaps. I'll close with this example, because you've all had that moment where you're standing at the edge of the room and you're thinking, how much pride or money or energy would it really cost if I just left and didn't walk all the way over there and turn off the lights? Or what if you just said, goodbye, goodbye. Thank you. Let's go drink.